Hey folks, so in this video I'm going to show you how to make some distance-based objective markers for your Unity games to help direct your players to your objectives. The cool part is with these markers is that they're drawn over all of the game objects in your scene, okay? So they're always visible regardless of any obstructions in your levels. This tutorial is slightly more advanced in topic. We're going to be writing some shader lab code with some embedded HLSL. So this video will be really long if I'm explaining how shaders work in Unity, so I'm therefore going to assume you're already somewhat familiar with shaders in Unity and just Unity in general. And if you're not, don't worry too much, you can still follow along with this tutorial and get these really cool objective markers up and running in your games. It's also worth noting that this approach will only work in the universal render pipeline, so if you're using another pipeline in Unity, then another approach might need to be taken to get these results that you want. But without further ado, let's get started on getting these in. Okay, so for this tutorial, I'm just using a blank Unity project. I have a first-person controller that I've made in my own time. You guys can make your own or take one from the Unity asset store. It's completely up to you. But here's our player, and we have two obstructions, okay, these two pillars. The idea is now we will set up a world space UI, which will be our icon, and then we need to make a shader for that icon to be drawn over everything within our scene from the universal render pipeline. So first and foremost, I need to install the Unity render pipeline, and I will show you how to do that. So we will need to head to Window, I'm going to go to Package Manager, Unity Registry, and we're going to type in the Universal. There we go, Universal RP. So we're going to install that, and once it's installed, we're going to add that to our project as well. Okay, now that I've installed the Universal Render Pipeline and it's added to my project, I'm going to go right click, create, head to rendering, and I'll create a URP asset with Universal Renderer, and we will name this URP. There we go, and we can now create a folder for that. Also name that URP. Select add to. Awesome. Now, we're going to want to head to our project settings, go to graphics, and I'm going to add that URP object we just created. Now your textures may turn purple. If they do, don't panic. What we can do is we will find our materials that we are using in our game. So in this case I'm using some meter materials. And all the ones that are purple, you can go ahead and select them. Head to Edit, Render in, Materials, and we'll convert these all to URP. And there we go. So now we successfully have the Universal Render Pipeline all set up and used in our project. Awesome. Cool. So now what we can go ahead and do is actually add in our icon. So let's right click on the player. I'm going to want to add a raw image, and that will create a canvas, which is what we want. We're on our render mode. We don't want screen space overlay, however. I want to set this to world space. Now what this would do is actually make it a physical object in the world, which is what we want. We don't want it this big, however, so let's shrink it down quite a bit. That would do. And if we go back to our player, find that UI, and let's bring it over to where we are in the scene. Awesome. So as you can see in the game view, we have our little objective marker. Very far away right now though, let's bring it a little bit closer. Cool. We don't want it this big still, we want it a fairly reasonable size, so let's squish this down a little bit more. Something like that. Cool. Let's bring this over towards our camera. Awesome. So here you can see this icon will act as our objective marker. Now you want your canvas kind of a reasonable size. That's fine. And then if you want to change your icon, by all means feel free. So click on that raw image. I will use the knob. Cool. And just a quick little resize of that. So here we go. So here you can see this would be our icon of the objective marker. Now the issue is with this, we can't see it behind icons. So we'll write a shader for this, but let's also add some text also for our distance. So UI, we use Text Mesh Pro. I do not have it imported, so I'll set that up. Awesome. As you can see now, we also have some text involved, just so we can see that in our scene. Let's turn that black. Awesome. I'm going to set this to 0, 0, 0. We'll align this in the middle. Voila. So this canvas, we can name this something like objective underscore marker UI. So this is our canvas. Awesome. Now, yeah, so we will set our player distance from how far we are using our text element here. But again, we cannot see these once they're restricted. So let's get right in on the actual juicy part of the video and get the shader in so we can actually see this get drawn on our Z buffer. Before I forget as well, we can unparent this. We don't want the objective marker UI as a child of anything. Doing that may move it, that's fine. Let's reset the position. It's looking rather large again, that's fine. We can shrink it back down. The scale tool. Let's bring it up a little bit more. Get it all in view, and then let's shrink that back down to something like that. Awesome. So yeah, this should be just on its own in the hierarchy. It doesn't need to be parented. If it was parented to the player, obviously this would move with our player, and you're not getting any closer to it. So it's kind of counterproductive to do it that way. So yep, unparent everything. Awesome. So shader, let's get on that. So if you want to go ahead and let's head to our assets, we're going to want to create a new shader. Shader. Here we go, and we want just the standard surface shader, that's fine. Let's call this draw icon on top. And we can go ahead and open up that surface shader. So by all means, it's highly recommended that you use the plugin for shader programming in Visual Studio. I don't have it installed simply because I don't really like it, but that's quite a personal thing. I'm not too bothered about the syntax stuff here for shader programming in Unity. However, let's get started on our actual shader. So we can go ahead and get rid of everything in our properties except our main texture. And we can go ahead and just get everything here as well for our subshader. We keep diffuse. Awesome. So for our main texture, we can get rid of this. So main text would be texture. It's going to be 2D equal to white. Perfect. So in our subshader, our tags v1q. Now these things are case sensitive, so just keep that in mind. Try and double check your spanning and cases. So overlay, render type is going to be transparent, which is equal to transparent. Perfect. Level details, just set to 100. Blend screen src alpha. That's 1 minus src alpha. Z right can be off, so we can draw above Z buffer, and Z test can be always, and call off when on screen at all times. Don't want to get rid of that. And now we go ahead and set up our paths. So CG program is quite important. So pragma, vertex, vert. Do another one. This will be our fragment. Frag. And then we will include Unity CG. CG Inc. Perfect. Let's abstract for our app data. And we can have a float 4. Vertex. Should be our position. A float 2 for our UV coordinates, and that'll be our text coord 0. That looks good. Seal that off. Have another struct. This time vertex 2 fragment. That's fine as it is. So have a float 2 here. Again UV text coord 0, and then float 4 vertex SV underscore position. Looks good. We can close that off as well. We want a sampler 2D. That'll be our texture. Float 4 underscore main text underscore st. Perfect. And then vertex defragment again. Vert update v. Cool. So here we think we vertex to fragment of the o dot vertex equals unity object to clip position. That's going to be v dot vertex o dot uv. That could be equal to transform underscore text, and then again v dot uv underscore main text. Very good. And then we can return O, and then one similar function but for our fragment. So fixed for fragment v to f I sv target. That's good. Wrap that up. A fixed for col a texture 2D. That'd be our main texture. And then return collider. Awesome. And then we have our CG program, so it's nNat end CG. Diffuse, awesome. So I don't have the plugin as mentioned, so the compiler won't complain to me, but the Unity console sure will if you have an error, which we do. Let's have a look. I see it. I've put text, quite literally, not text for texture. Another one, still at 49. Okay. I see again. I've done it again here. Main text. We don't want that. Main text or texture, which matches correctly. There we go. Awesome. So there's our shader. It's compiled. It's happy. And now we can go ahead and actually use this in our scene. So let's do that. So we're going to want to create a material to use with our new shader. So material. Let's call this obj underscore map for object material. And now up here for shader, we're going to need custom. And you will see the draw icon on top shader that we just made. Perfect. Now, as I've shown you, so if we drag this behind our game objects, it can't be seen. However, if we now, in the material slot here, just drag in our material that we just made for the icon, voila. You will now see that this shader, or the material that's using the shader, will now draw our icon above game objects, which is great. We need to do the same for our text. Our text is not able to be seen, so we're just going to have to quickly write one more shader, kind of very similar, but just for our text element rather than a raw image. So let's get onto that. So same again, what we'll do, we'll right click, create, and then we're going to look for shader, standard surface shader. And we'll call this one draw text on top. Go ahead and open up. Cool. Now, same again, we can get rid of most of what's in here. Don't need all of it. We'll keep main texture. It's fine. We can just go ahead and get rid of all the subshader stuff too. Now, draw icon on top works for icons specifically in the universal render pipeline. Now, we're using TextMesh Pro, so we need to do the same again, but this time rather than using a text element, drawing a text, raw image, sorry, we will now draw some TextMesh Pro instead over that. So, we can keep most of this, still equal white, but we can get rid of all of this. And we want to use our font, Atlas, which is just the standard font that comes with TMP. 2D equal to white, that's great. Face color, American, spanning. Face color, and color, that will equal to white. Outline color. And color again. This time it's going to be equal to 0, 0, 0, 1. And outline width. Can be range, so 0.02 and 0.0. Cool. That looks good. In our subshader for our tags, we can set Q equal overlay and render type transparent. Edit these 100 again. It's fun. Blend the screen alpha 1 minus src alpha. Cool. As z right is off. At z test it's always, or what's always, and cutting can be off. Awesome. Now let's set up our pass. CG program. Set up our vertex. Vertex vert. And then we'll set up our fragment. For our Unity CG. CG Inc. And we'll throw in our struct again. Our app data. Float 4. Vertex. Position. Float 2. UV chords. Section chords. 0. That looks good. Close this up. Another struct. Vertex to fragment. Flip 2. UV. Position. Separate these. 2. No, we need to put 4, sorry. Vertex. Sorry, no. This would be our SV chords position. And this would be a text chord. Cool. And then we can throw in our sampler. 2D underscore main texture. We'll throw in a float 4 for our face color. Float 4 again for our outline color. And a width. We'll throw in a float for our outline width. Awesome. Then vertex to fragment, vert for an app data, that would be v. Vertex to fragment, specify that to O. O vertex equals unity object to clear position. V dot vertex. UV, V dot UV, and return. Looking good. Then fixed for let's do fragment I. Is that SV target? So, fixed for face color would be face color, outline color, outline width, fixed for texture 2D is our main texture. I.UV float distance equals col A, that slash, dot there. Then float width equals float width, throw in our distance. Float alpha equals smooth step, say 0.5 minus that by width 0.5 plus width distance. Spell that correctly. Looks fine. And then our outline. Smooth step that as well. Say 0.5 by our width minus our outline width. 0.5 plus width plus outline width by distance. Then our RGB will lerp our outline color. RGB, our face color. RGB, and for an alpha. Col A equals outline. So we'll draw our outline on that, and then we can return this. Cool, and then we need to end CG. But our fallback is going to be text mesh pro distance field FIELD. Okay, let's see if we get any complaints on the console. We do. Let's have a look. What line? 39. I see. We missed a capital here. Still complaining. Yep. Oh, there's another mistake here. I've also spelt face colour the British way. Let's correct that. Another one for a typo somewhere. And I also forgot to close the struct here. Forget semicolons. Cool. So that's all happy now. So I can go ahead now and click on our text in our objective marker. Down here on our shader for our font, we can set that to draw text on top. Voila. Now that will come out white. That's fine. That's how we set it in the shader. We can set this back to black. There are some extra customization features if you want here. You can probably set this up further to use different font atlases also. But now you will see, voila, it's all drawn on top. So this is a good point now where we can set this up to start displaying our distance from the marker from our player. And also notice as we get closer to it, it doesn't shrink. Ideally this icon should get smaller the closer we are to it, and then get bigger the further away from it. And as well as this, it doesn't rotate and face the player either. This should always face the direction of the camera, so we want to billboard this as well. So let's write some C# scripts to start get that set up now. So let's start nice and simple with the billboard. So we go ahead and create a C# script, call this billboard. And we can go ahead and attach this to our objective marker UI canvas. And we'll have that rotate to consistently always face the forward facing part of the camera. So let's add that. Our billboard. Go ahead and edit. Super simple script, okay? We'll just transform this. So we'll make a reference to our camera. Void. In our start, we can reference our main camera. And then in our late update, you can say if main camera equal null, you can say vector3 direction equals main camera dot transform dot position minus transform dot forward. Sorry, position. Main camera transform position, that looks good. Direction dot x is equal to direction dot z equals 0.0f. And then I transform again. Dot look at, set our direction to our main camera. Dot position. And then we'll rotate 180 degrees on our Y. That looks good. Let's test this. Awesome. There we go. So now you can see that regardless of where my player is, it's always going to be facing the camera. So it looks like it's not actually a 3D object in the world. But it's a world space UI element, so it is. But smoke and mirrors. So cool. Now let's get the distance set up, and then we can look at shrinking this as well. Now we can go ahead and create another C# script on our text. So let's go ahead and create a C# script. Let's call this distance display. Go ahead and open that up. And we'll attach that to our text mesh pro text element. So component, distance display, and we can go ahead and open that up. Awesome, let's get rid of all this. So first we're going to want a public transform for our player. Now you don't necessarily have to have it as your player if you don't want. It could be anything that has a transform in your scene. But for the sake of this tutorial, I'm going to use the player as my target. So take this, we text mesh pro. That not automatically included it for me, but if it doesn't, make sure you're using the text mesh pro namespace. Otherwise, you'll get an error for that. So public float. Let's specify our max scale distance. So that's something like 50. We'll do another float for our min scale distance. So that's something like 5. We want a public vector 3 for our max scale. So that's something like 2 by 2 by 2. And we'll do another one. You guessed it, our minimum scale. You can set this like 0.5. Cool. And we can add our start function. Void start. If player equals null. Let's do a null check there. We can then player equals game object. Find that player tag. Find game object tag. So I'd like to player. Game object with tag. Then we can public void update. Update method float distance equals vector 3 by distance, and we use our player position, a transform, and position. Cool. Text mesh pro text is then equal to our distance to string fo plus cool float scale equals the math f, and then we can inverse lerp and max scale to distance, min scale distance, and then distance. Transform dot local scale equal to vector 3 dot lerp by our max scale, minimum scale, and scale. Awesome, that looks all good. We can test this. Set our player, so my player controller and Text Mesh Pro with this. Now, maybe set this something a little bit higher in the inspector. Try 8 by 8 by 8 by 2 by 2 by 2. I want my max scale distance 325 and then 10. Let's give that a test. Okay, cool. And then as I get closer, that all updates. Awesome. Now, as you can see as well, I need to tweak the values a little bit, but as I'm getting further away, it's getting larger. And as I get closer, this starts to shrink as well. You might want to include the same thing for your icon, but to make my life a little bit easier, what we can do is just attach our raw image or parent it to our text, so that will update together. So there we go. So now a nice big marker when I'm far away, maybe a little bit too big, but as I get closer, that starts to shrink a little bit. Awesome. And yeah, they can still be seen all behind game objects as well. So let me tweak this to something a little bit more reasonable. Cool, so I've played around with these variables a little bit. I found these are kind of best for this, what I'm showing you. Obviously in your case, in your projects, it'll be a little bit different, depending on how far you want the player to be when it starts to get bigger and smaller and whatnot. However, here I am, 15 meters away, and as I get closer, you will see, here we go, it gets nice and small as I get close. Now, it's up to you how you want to handle your objective markers when you actually get to them. Perhaps you could want to turn them off or activate some sort of trigger from here. But yeah, you can set up several of these and they're all toggleable. And the cool bit is, with the implementation that we've took, is that you can still quite easily customize these if you want. So if I go to my raw image, I can set a different graphic if I want. Maybe I want the background or some sort of UI icon that you have specifically. And these will still work being drawn as well. As long as it's got that shader attached, which it does, you're fine. And yeah, you can obviously build upon this further and potentially change things to how you want it for your project specifically. But I think this is quite a broad implementation and quite customizable from here. So I hope this was useful to some extent for your Unity projects. And yeah,